Okay, up next, our last presentation of the session. We've got Alejandro Mosteo. We're going to keep going with client library support here and talk about the work they've done to get ROS2 working with Ada.
Thanks, Brian, for the introduction. I'm Alejandro Mosteo. I'm going to talk about Ada and ROS2. And basically, I will begin with a bit of spam about us, and then I will try to convince you that Ada is a proper addition to the ROS2 ecosystem. We will see how it fits with the ROS2 infrastructure. I will end with some examples. So, two of the authors come from the Defense University Center in Zaragoza, which is kind of the Spanish West Point. And we also belong to the Robotics Perception and Real-Time Group of the University of Zaragoza. And there we do research with robots, and it's a big group. There's over 25 faculty members, but the research lines that are close to me are, well, distributed algorithms and interventions in hostile environments. We are moving now to autonomous drone flying in GPS-denied areas. So that's the kind of problems we want to tackle with ROS2. The other part of the contributors to this work is people from Ada Core, which is the original authors of the Ada compiler and currently the main contributors and maintainers. The Ada compiler from the Free Software Foundation is part of the GCC tool suite, and, well, they have presence in many critical industries. Basically, this talk is to say that we can now write nodes in pure Ada. And to understand what Ada is today and how it's come to be what it is, I will talk just a bit about history of Ada, which I find very interesting. So in the 70s, the Defense Department found that they had over 400 languages on their systems, and that was a maintenance nightmare. So they tried to find the one language to unite them all, and because they saw that no existing language could fit their requirements. So they did a contest. They first selected 4 candidates, and the green candidate won from a team led by Gian Ekbia, French team. And the winner was renamed to Ada to honor the first computer programmer. It became a standard, and for a few years it was mandatory in the Department of Defense, unless you had a very good reason to avoid it. And that resulted in a bit of backlash against Ada. But in the end, what we have today is that, thanks to that, we have a language that was designed for the requirements of such a large organization, from the smallest embedded, high real-time requirements, but also very large systems, distributed systems. So Ada was designed basically with many of the needs we have in robotics today. And it still can be found in many critical contexts. So Ada, if you have not seen it, is kind of derived from Pascal in its syntax. It has all the expected features of a modern language, and also some of them that are quite specific, like design by contract and high-level concurrency constructs that are totally portable, which is also a strong point of Ada. And basically it targets the same domains of C++. Ada is no silver bullet, and no language has a solution for everything. But in the end, it's about the culture that surrounds the language and the driving forces behind the decisions. And in the case of Ada, it's to write safe code in critical environments. It's a language that has evolved with the years. There's a group of experts and compiler writers that adopt new features with backwards compatibility. And just to, everything is standardized in the Ada reference manual. And for example, there is a test suite that certified language compilers have to pass that covers corner cases of the language. As language become bigger and more complex, there are some things that can become undefined if you don't test for them. So, with the new emphasis on ROS2 about moving to a more from research prototype into more industrial setups, and more focus on real-time and embedded systems. It's exactly the kind of domain in which Ada is perfect to work with. Also, for the more stringent needs, Ada has a subset named Spork that allows you to prove properties formally of your code. So that's really expensive in time and effort, but gives you maximum security about your code. Now moving to ROS2 and how all this fits with ROS2. This is the classical architecture for client libraries. As Steve told us, one of the really neat things about ROS2 is that we have the ROS client layer that is common to all client languages, except for a few things, as I found out, like threading model and zero-cost intra-process communication, which is not in this layer. So our contribution in this work is basically this, a new binding to this ROS client layer, and some examples in Ada code. But also something which is not so commonly talked about is the interface description language, which is what gives us the types for the message, and which is also very necessary when you are using a client library. Finally, Ada has a powerful tasking model that is used in this library, but there is still no zero intra-process communications. And, well, this is at the architectural level. Those are no actual ROS packages. When you go to actual existing ROS packages, you find something more like this, where red blocks are pre-existing ROS2 packages, and the green blocks is our contribution, with some examples which are in blue. If we reorganize this something, we get a more classical top-bottom organization. At the bottom of it all is the Ada tools, basically the compiler, and the Ada building system. Ada mandates that the build executables have some qualities, like you don't mix outdated sources or objects, that your initialization order is valid. You cannot have the order fiasco problem of C++, for example. And on top of this are the 3 packages which give the Ada library functionality. One of them is to integrate the Ada build system in the callcon build process. Another one deals with the message support, and finally we have the proper binding to the RCL, and also the examples, which are just regular Ada programs. So when writing a binding, you have 2 ways to go. Basically, you can do it by hand, which results in better code because it's written by a human, and it has the spirit of the language. And you can go with an automated tool, which the advantage is that it gives you perfect matching between functions in both languages. Each has its advantages and its problems. Ada has support for both because you can generate Ada specifications from C headers. And in the end, what we did was to use a mixed approach in which when you build the binding for the first time, thin binding automatically is generated, and this thin binding is used by a high-level binding, which is written by hand, and which is the one that regular users are expected to use. So this way, if anything changes in the C API, that would be immediately detected because a compilation error would happen. About the level of completion of the library, it's complete for the most part. The only thing doesn't exist yet is the static code generation for messages that Steve talked about in the first talk of this session. Instead, what I did, because it was simpler at that moment, is to use the introspection capabilities of ROS2. So this way, there is no generated code for the messages. And how does this look? It looks like that. You index the fields in the messages with their name. This obviously has a small runtime penalty that will be eliminated when the static part exists. And basically, there is support for all types in ROS2, also for one-dimensional arrays or matrices of any size, any dimensions. Everything is checked for type and bounds, so it's safe to use in all senses. And now moving to the first examples. Here we have the canonical talker example, which I have chosen to show using Ada tasking, just to highlight that Ada has had since the beginning, for example, built-in types for time, constructs to have loops without drift, for example. And also of note in the tasking model of Ada is that tasks have masters, which is the scope that created the tasks. And even if your main thread of execution ends, the program will wait for all the tasks that are still running, so you don't have a suddenly death of your program and all his tasks or things like that. The listener is similar, just using the callback approach. You register a callback and you get there your messages. And there's really nothing special about that. I will skip the server and client because they are not anything new. If you are interested in these samples, they are available online, as the rest of the library, of course. And now I arrive at a point of the library that I think is, at least I think it's a bit different, is that everything is stack-based, because as we saw yesterday in this excellent talk about autonomous vehicles, heap allocation is in principle not deterministic. So using the stack avoids that problem, and Ada has very good support for the stack with indefinite types, which are types that have an unknown size, but all their values have a known size at runtime. So when you declare a variable, you have to fix the size, which cannot change, either by giving the bounds at that time or by initializing at that moment the variable. And this way, many things that normally would be done with dynamic memory can be done in the stack. And there are no dynamic allocations in the RCL part of this Ada binding. For example, this is the multi-task support in the binding. You have the executor type, which has several discriminants, which is the terminology in Ada for this kind of constructs. And you initialize the executor with the number of nodes, the size of the queues, the threads that are in the pool, and the priorities, and everything is created in the stack. And this way, we avoid the problem of heap allocation. Another point of note is, for example, the use of allocators. ROS2 has an emphasis on the control of the memory, and for that defines a type which is an allocator, which allows to write custom allocator, custom memory reservation. And Ada has this built in the language, so basically in this area what we do is map ROS2 allocators to Ada memory storage pools, which is the Ada name. And this way, they can be used transparently both in ROS2 and in Ada. And for example, this allowed me immediately to test the memory allocation in both ROS2 and the library with the debug pools that come with the compiler, where I can check that all allocations that happen during initialization have their corresponding deallocations, and that there are no memory leaks, nor unexpected heap allocations during the looping. Finally, to conclude, just a note about Spark, which is a proper subset of Ada. That means that can be compiled with the same compiler, and that uses the design by contract features of the language to prove things about the code or to detect problems with the code. For example, we have preconditions, postconditions, or we could have a type that ensures that only prime numbers can be stored in this kind of variable, Of course, this would be expensive to check, but you can remove the checks once you prove your properties of your code, for example. And so it targets specialized needs like pharmacy, those two. Anyway, for those that are formally minded, just take a look. I have also, sorry, I forgot to say before, I have 2 books, a few copies of those 2 books, courtesy of Ada Core for free. I will leave them in the overflow room. So if any of you is interested on one of those 2 books, you just go and pick them. It's about Ada for C++ developers or about Spark and Ada examples. There are some very well documented open source projects using Spark that you have in the slides if you want to check them more in detail. And basically this is all. We have now a new client library for a language that is very well suited to critical domains like robotics is. And well, we hear every day that the autonomous car is around the corner, but for example, when you climb in a plane, you know that the code in that plane has been very thoroughly verified, certified, and so on. And we don't know what will happen with the complex algorithms that are now in the autonomous vehicles. So those problems are also around the corner. And finally, well, that's it. You have, well, I want to thank the people from ROS2 that helped me a lot with my many questions. I was a newcomer to ROS2 when I started the binding. And everything is online for you to check and play. It's already working, so that's all. Thanks.
Thank you. Do we have any questions from the audience? Andres.
Yes, hello. Of course, a system is only as safe as the weakest link.
Yeah.
And so we have a lot of other weak links. I mean, I think it's great that you have these other ROS, but the links below, like especially DDS implementation, are still quite weak. Do you plan to put some resources and efforts into also looking into these issues and bringing the whole RCL and the RMW and DDS implementation up to the same standards?
Well, actually, I'm not part of the core team that develops those parts of ROS2. So I personally, I have no plans nor need for my research. So that's all I can say about that. Sorry.
You know, all it takes to join that core team is to start contributing to the GitHub repos. So
Okay, okay.
consider that to be an open team.